Hey everybody, this video is meant to help you out with a lesson 6 cool down. Problem says the sequence has the recursive definition g of 1 equals 3/4, g of n equals g of n minus 1 times 4/3 for n is greater than or equal to 2. First we want to write the first 5 terms of the sequence and then we'll sketch a graph of the first 5 terms of the sequence. Alright, so let's look at what this definition is telling us up here. First and foremost, all of our recursive definitions tell us the initial value. That's what this whole part, the first section, is telling us. It's our initial value, basically what the sequence is going to start with. Talked about in class. So that means if I'm writing the first term of my sequence, I know for sure that the first term is going to be 3/4. Yes, it's a fraction. You can convert it to a decimal if you really felt like working with it, but I would prefer to leave it in a fraction personally, so I'll do that. All right, then we're going to have another term, and we got to figure out how to get to it. All right, the next part of our definition is g of n here. That's standing for the next term. It's basically saying to get to this next term, it's going to be equal to, well, g of n minus 1 right here. G of n minus 1 is standing for our previous term. It's not equal to the previous term. I'm going to abbreviate this as PRV term. It's not equal to the previous term just by itself. It's equal to the previous term times 4/3. Since we're multiplying by 4/3 here, this is our growth factor. Multiplication means we're going to have this geometric sequence. So this right here is going to be our growth factor. We have our 4 pieces here. All right, so what we know is we start with 3/4 to get to the next term. We're going to take that previous term, 3/4, and multiply it by the growth factor, 4/3. That is, I'm going to go 3/4 times 4/3. All right, off the top of my head, I'm not sure. Let's do it off to the side and think about what this is going to be. So right down here, what's 3/4 times 4/3? Zoom in a bit. So write more neatly. We're going to have 3/4 times 4/3. 3 times 4 is 12. We multiply the two numerators together. And 4 times 3 is 12. Multiply the two denominators together. Common mistake is that people cross multiply here. We can't do that. We can't cross multiply when we have a multiplication symbol in between. We can only cross multiply when this is an equal sign, so don't do that. 12 times divided by 12 is obviously 1. So that means the next term of our sequence is 1. And we can keep going. I'm going to multiply 1 times 4/3. This one I shouldn't need to show the extra work for because, well, I know that multiplying 1 times anything, even if it's a fraction, will just be itself. So 1 times 4/3 is 4/3. All right, and then to get the next term, the fourth term of the sequence, we're going to take 4/3, and again, we're going to multiply it by 4/3. Multiplying 4/3 by itself, aka squaring it. So I'll do this work down here. If we have 4/3, and we're multiplying it by 4/3, it's going to be 16 over 9. All right, so there's the fourth term, and we can do this one more time. Times 4/3. All right, I've got to do the side work over here. 16 over 9 times 4/3. 16 times 4, if you did that in your head or with a calculator, you should get 64. And 9 times 3, you're going to get 27. So the last is 64 divided by 27. All right, and that's how we can find all of the terms of this sequence. Next part, we're going to need to graph them. It might be more helpful for you to turn these into decimals to graph them. So if you use a calculator, you'll see that 3/4 is equal to 0.75. Obviously, this stays as 1. 1 is just 1.0, but I don't need the 0.0. 4/3, if you use a calculator to do that, you're going to get 1.3 repeating. 1 and 1/3, basically. If you do 16 divided by 9 in a calculator, you're going to get 1.7 repeating. And if you do 64 divided by 27, you're going to get 2.37. Decimal keeps going. It's actually 2.370, and that repeats. So I'll actually write that 2.370 repeating. So now I can use these points to help me graph. First term is 0.75. Second term is 1. So let's put this onto a quick little graph. When you do it, it doesn't need to be perfect. All right, on here I have 5 terms, so I'm going to put 5 values along the x-axis, the horizontal axis here. So I'll have for term 1, for term 2, 3, 4, and 5. We've seen like steps in class, so these are terms. Or term numbers. It's like term number 1, term number 2. And then going up this way, well, I know the smallest value I have is like 0.75, so 0, and the biggest is 2.370. So I should go up to maybe 3. So I'll go by halves. So let's call this 0.5. We'll go to 1, 1.5, 2, and then we'll have a 2.5. I don't go above 2.5, so actually I'll stop here instead of all the way up to 3. All right, so we know term 1 was 0.75, so that's halfway between here. There's our first point, 1 and 0.75. If you want to write the point, you can. I'll do it just for this one, 1.75. The second term we saw up here was 1. So 2, 1. The third term was 1.3, 4/3. So a little less than here, so about right there. Not quite at 1.5 yet. Fourth term is 1.7. So somewhere in between 1.5 and 2. So like right here. The fifth term is 2.37. So something like right here. All right, and there is a graph of our sequence, and we have represented it in different ways. All right, hopefully this helps. I'll see you next time.